Hello, my name is Carmen Willmore. I'm an extension educator with the University of Idaho located in Lincoln County. And the presentation I'm going to be discussing today is utilization of drought damaged feeds. So over the past year, I think we all, are very aware of what's been happening. We are low on precipitation and irrigation water in some areas, and coupled that with very high temperatures, which has kind of been the theme for the past few years. And we ended up with a pretty significant drought this year, causing quite a bit of damage to some of our forages. So because of that, and couple that with our high hay prices and high feed prices, quite a few of us are looking at having to learn how to utilize our drought damaged forages. But drought damaged forages probably the number one question that we receive in extension, and I think probably one of the number one concerns that a lot of producers are facing is nitrate accumulation, right? So drought stressed forages are notoriously at risk for nitrate accumulation because of the lack of water and the high temperatures. That kind of creates the perfect storm for nitrates to get locked up in those forages, unable to turn that into protein, and then can cause some pretty significant poisonings in our livestock if not monitored and tested and monitored and fed appropriately. So forages that have undergone this drought stress should be tested prior to harvest or grazing. So I think some people historically have thought, oh, if I just cut it, the nitrates kind of dissipate out, just kind of like some of the other forages. Once you cut it, those prussic acid poisonings, things like that, release, but that's not the story for nitrates. When you cut that, if it has nitrates in the plant, they're going to stay in the plant. If you are ensiling it, so if it's haylage or corn silage, something like that, ensiling can reduce the amount of nitrates in the plant as it goes through that ensiling process. But if you are cutting it for hay, it will not change. What you cut it at is what it stays at. And obviously the same can be said for grazing. If you're going to put cattle out into a field that could have high nitrate levels and they're going to be grazing it as just fresh feed, that puts them at risk as well, because whatever's in the plant is what they're going to eat and be exposed to. So small grain regrowth such as barley, oats, and wheat should always be tested. Those are known nitrate accumulators because they're fast growing plants. And they can bring that nitrogen out of the soil, but then if they don't have the water and the sunlight to turn that into protein, then it kind of gets locked in there as nitrate and can cause poisoning issues. And then a couple of weeds to look out for are lamb's quarter and pigweed. They're also known to accumulate nitrates and can be pretty dangerous if there's a high percent of these in the field, in and around the field that might be grazed or harvested. So nitrate poisoning, so under normal circumstances, nitrate is converted to ammonia and then bacterial protein, and there is little buildup in the actual plant, right? So it goes from forage nitrate, nitrite, ammonia, and then protein by the rumen microbes. So it just gets utilized by the animal. But when there are higher amounts of nitrate being consumed, so if there's higher amounts of nitrate in that forage, an accumulation of nitrite will happen faster in the rumen than it can be converted to ammonia and then that microbial protein. So you have more nitrate coming in that's converted to nitrite, but then the nitrite to ammonia part is slowed down. So instead, that nitrite still has to go somewhere, right? So it's absorbed into the bloodstream and will convert hemoglobin to methemoglobin, and methemoglobin is unable to transport oxygen in the bloodstream of that animal. So the animal will then actually die from the nitrate poisoning due to that lack of oxygen. So the blood is not able to transport oxygen like it normally would because it has a higher percentage of methemoglobin in the bloodstream. So this is just another way to look at that. So you have your high nitrate forage that's being consumed into the rumen. Normally it goes from nitrate, nitrite, and ammonia, and then that ammonia gets used up by the microbial protein, right? Or the rumen microbes into microbial protein, excuse me. And then that nitrite, if there's too much of that, is going into the blood. And this is the problem that causes this nitrate toxicity and the poisoning of our livestock, is when there's too much nitrate converted to nitrite, and then they can't use that up. So the nitrate accumulation in forages kind of happens as the plant tissues accumulate nitrate during the night when photosynthesis is inactive, and then it peaks in the morning. So this is another thing where when I'm discussing this with producers, I tell them, don't put the cattle out till the afternoon, fill them up so they don't just go out and eat everything that they possibly can, right? So they kind of have a full stomach, but also it gives the plant time to kind of use up that nitrate and turn it into protein as photosynthesis is ramping up throughout the day. The nitrate can be quickly converted to protein when there is adequate sunlight and water. If there's not water, it's not able to complete that process either. And that's why the presence of sunlight and water is very important. And in some cases, the roots will accumulate that nitrate faster than the plant can convert it to protein, or the plant undergoes some type of stress and is unable to convert nitrate to protein. So this is pretty significant, especially if you're putting down fertilizer. A heavy rate of nitrogen fertilizer can also cause some toxicity issues, especially after it's applied and being used by the plant. It's not converting that to protein as fast as we may like, especially if there isn't enough water for it to complete that process. So some of those stresses on the plant that can cause nitrate accumulation is hail, frost, long cool spells, drought, which I'll talk about here in a minute, pests, disease, herbicide, and shade. So really anything that's going to cause damage to that plant and slow down that process of converting the nitrate to protein is going to lock the nitrate into the plant, right? If it can't, it's going to bring it out of the soil by those roots, but if it can't use it up and turn it into protein, then it's just in the plant as nitrate and not protein. So drought causes a plant stomata to close in order to conserve that water, right? It wants to keep that plant alive and growing, so it's going to lock it all up and conserve what it can. So when that stomata closes, it also restricts carbon dioxide availability to fuel photosynthesis, and growth essentially stops or stalls, right? And so when that photosynthesis is stalled, nitrate again will build up in the plant. So this is what's happening right now with a lot of our plants that are under drought stress. They're trying to, grow and be green and flourish, but if they don't have the water, they're just going to kind of stall right where they are, and that can lock in the nitrates as well. So what do we do, right? We have these forages. They might be safe to graze, but we really don't know. I don't want to just stick my cows out and, maybe lose a couple, lose half of them, whatever it is. So what we can do is we can test for nitrates. So there are 3 tests that we can use. We can use the quick test, which is a qualitative test, which just detects the presence of nitrogen. And this is done. Most extension offices have this capability, or they know of a place locally that you can get it done. There will be a list of nitrate testers in Idaho that'll be up on the drought page after this presentation. So you can just find someone on that list that is close to your location, bring in a forage sample, and they should be able to test it for you. But this is a quick test. So in this test, up here on the right-hand side of this page, you can see that there is a lot of dark blue. That's not what you really want to see. If it turns dark blue, that means that there is a high level of nitrates in the forage that's being tested. So I believe in this example, this was over 10,000 parts per million when I sent it in to have it have a lab test run on it, which is unsafe for grazing of all classes of livestock. So in this specific example, this producer, I believe, waited a while, let the plants continue kind of trying to use up the nitrogen, use up the nitrate, And then we retested, and I believe we finally got it to a level that was acceptable for grazing. So the second test is a strip test. This is a semi-quantitative test that involves a little more processing of the forage sample on the tester's side. They have to dry and grind that sample and then put it on the strip test. I myself in Idaho am not qualified to do this test yet. I'm hoping to get the training and the equipment to be able to do this test in my lab. There may be some other educators in Idaho that are. It's a little more accurate than the quick test because it gives you a little more of a range of where that forage sample falls within the feeding guidelines, but it's still not as accurate as a lab test. But it is quicker than harvesting that sample and sending it off and waiting to get the results from the lab test. So the quick test, you can have results in 20 minutes. The strip test, it may be more a couple of hours as you dry and grind that sample. And then the lab test can be a couple of days as you wait to get those numbers back. But the lab test is by far the most accurate. Usually I will do a quick test, and if I see any blue in my samples, I will send it to the lab just to get a number on it and know what they're really working with. If you want more information on this, Montana State Extension has put together a great guide as far as these tests. There's a link here on this presentation if you want more information on these tests. A really important thing about testing your forages for nitrates is bringing in a good representative sample of the field. So what I tell people is to either walk the field or get on your four-wheeler and pull out, 10 to 15 actual plants of what the cattle are going to be eating. And I say this because when I do the quick test, I go to the bottom node of that plant. So I go all the way to the bottom where the roots are, and I follow that up and I find the first node, because as the forage is pulling that nitrogen out of the soil, it comes through the stem first. And so it will actually accumulate in the nodes. And so it's important to test the node because that's where the nitrates are accumulating, right? So if there's going to be nitrates in that plant, it's going to be in that bottom node. And so that's what I always test, because if that's positive, then I know it has nitrates. And so I ask people to bring, 10 to 15 plants, because then, you can get a better grasp of what's happening throughout the entire field, not just where they hopped off their horse or their four-wheeler in one spot. You really want to know what's happening across the entire field. So once you have submitted your samples for testing and have received your results, you will know what you're able to use that forage for. So this is a table again from that Montana State Mont guide on nitrate toxicity of Montana forages. And this is pretty general. Most laboratories will also give you feeding guidelines and recommendations based on the results that they send you. But if they don't have that, sent with it, you can consult with your local extension agent or myself, and I can help you come up with a feeding plan based on the results that you get. But in general, if your results come back at less than 1,500 parts per million of nitrate, that's generally considered safe for all livestock to consume. Once you get over that 1,500 mark, between 15 and 5,000, it should be limit fed to 50% of the ration for calves, pregnant or lactating animals. For some of your stocker and growing cattle, they can usually tolerate this range with monitoring and kind of acclimating them onto this range of forage. So putting out another feed source, filling them up before they go into the field, and putting them out later in the day so that those nitrates aren't as high when they first get into the field. And then anything between 5 to 10,000 should be limit fed, between 25 and 50% of the ration, and not fed to pregnant animals. Again, this goes back to the conversion of hemoglobin to methemoglobin and the the lack of oxygen in the bloodstream. So that means that less oxygen is also getting to that fetus of the pregnant animal. And so that's kind of where the risk is with feeding at this higher level to a pregnant animal, and why it's not recommended to feed anything in this range to pregnant livestock. And then obviously anything over 10,000 parts per million should not be fed. It can cause animal mortalities, pretty significant poisonings. And so if you do test something that high and you have not harvested it, so you haven't cut it or anything, you can give it some time. Sometimes they will come kind of down out of that toxic level where you could harvest it or graze it safely. If it is already harvested, you can ensile it if that's still a possibility, or find another avenue for it, because it would not be safe to feed even at a very small portion of the ration. So nitrate toxicity symptoms to look out for. So signs of early or chronic toxicity would be watery eyes, reduced appetite, reduced milk production, kind of a unthrifty appearance. They can start to lose weight or have no weight gain, and then night blindness and abortions, all because of that, lack of oxygen in the bloodstream. Signs of an acute toxicity, so a very fast kind of, they got it way too much all at once, would be that accelerated pulse rate, labored breathing, shortness of breath, muscle tremors, weakness, staggering gait, cyanosis, and death. And that is all because of that very rushed nitrite entering the bloodstream, binding up that hemoglobin, and reducing the amount of oxygen in their bloodstream. So recommendations: always test before you graze or feed any of these drought-stressed forages so that you know what the levels are. And if they are high, you can wait for more favorable growth conditions to hopefully let those forages kind of come down in their toxicity or their nitrate levels to a safer grazing level. Dilute your high nitrate forages to safer levels, whether they're harvested forages that you're mixing in a ration with some lower feeds and forages that are, in a safe range, or if you are grazing them using the right class of cattle that aren't at risk or at as high of a risk for poisoning, so that they can graze them safely. Toxic levels of nitrate can accumulate in forages immediately after a drought-ending rain or irrigation. So wait about a week before harvesting or grazing after the moisture event, and then avoid cutting or putting out to a new field first thing in the morning, as you want those plants to kind of start using up that nitrate and turning it into protein, so that it's not being consumed by the livestock as nitrate. So if you have further questions, definitely reach out to me. My name is Carmen Willmore. I work for University of Idaho Extension, and I will have my contact information on the details of this YouTube video. Thank you.